everyone. I'm Kara Erickson. I'm a senior software engineer and TLM at Google working on the Chrome team. And I'm here today to talk to you about image optimization. We'll start by talking about the team that I'm on in Chrome and how we collaborate with the Angular team. We'll talk about the Angular image directive. We'll jump into a demo where I show you how to use the image directive to optimize your images. And then we'll circle back and kind of do a deep dive on how it works under the hood and why it actually improves performance. So to jump right in, you might be wondering why a Chrome person is here to talk to you about Angular. And the short answer is that I work on a very particular team in Chrome called the Aurora team. Aurora is an initiative where Chrome engineers collaborate with open source web frameworks and tooling to make the web better. And specifically, we've been focused on web performance. So for the past year or two, we've been collaborating closely with the Angular framework team to try to build performance best practices into Angular. And we've started by focusing on this one metric, LCP, or largest contentful paint. If you haven't heard of LCP, it's a metric that measures how long it takes for the largest image or text element that's visible on the page to complete loading. So you can also think of it as how long it takes for the user to have enough visual information to know whether the page is actually useful to them. But we can't talk about improving LCP without talking about improving images. And that's because for 80% of desktop pages, the largest contentful element is an image. So images are a really important part of this conversation. The problem is, it's really tricky to get image optimization right. There's a ton of best practices that you have to remember. I dumped a bunch of them on this slide to make a point. You don't have to read through all of them. But the idea is that it can be really hard to stay up to date. So the thinking from the Aurora team was, if we could build some of these best practices into something like a directive or a component, then you wouldn't have to remember all of them, stay up to date, keep updating every year or whatever it is. You can just use the directive, and then it would kind of do the rest. And so we've collaborated with the Angular team to create ng-optimized image, the Angular image directive that came out in developer preview in 14.2. And as Minko mentioned earlier, it's on track to become stable in version 15 next month. So this is a really great time to try out the image directive if you haven't had a chance to test it out yet. So on the Aurora team, we are at the point now where, since most of the features have been implemented, we're trying to actually validate the performance outcomes with real websites. So one of our partners is Land's End, which you can see on the screen. They're a clothing brand in the United States, and they've been kind enough to help us test the image directive in their QA environment. So in these early lab tests, they ran Lighthouse a number of times before and after using the image directive, and then took the median LCP. And what they found was a 40% improvement in the median LCP on mobile, and a 75% improvement in the median LCP on desktop. So we're really excited to see these these early results that can show the potential impact that the image directive could have on real applications. Although I do want to give a quick caveat that the gold standard for performance measurement is using real user data, so production data in the field, and we're still trying to collect that. But hopefully that's intriguing enough that you'd be interested in seeing a demo of how to use this thing. So I built a basic demo application that uses native image tags. And what we're going to do is convert all the images beneath the fold to use the image directive, convert the hero image to use the image directive, resolve any warnings or errors that are in the console, and then check to see how it impacted performance. OK, so this is our app. And so it's kind of, there we go. So it has, a basic H1 title. It has an image of my cat, Hermes. There's a bunch of filler text here. There's another image of my cat. More text. There's another image of my cat. you can kind of see where this is going. There's 7 images total of Hermes, and I'm emulating here on a Moto G4 device just so we can see what this would look like on mobile. Okay, and if we look at the code for this, it's similarly, oops, this is really big. It's similarly pretty simple. I dumped all the code in the app component just to make sure that we're not jumping around. But you can see, yeah, here's the title that we just looked at. Here's the hero image. It's just a native image tag that binds to the source, width, and height here. We've got all our filler text. And then here we have an ng4 that iterates over all of our images. And each of these images is also an image tag with source, width, height, and alt text bound. And if we look at our TypeScript, you can see the objects that are backing these bindings, and these are just our source URLs and a bunch of dimensions. Okay, so if we wanted to convert this to use the image directive, go to our module and import the ng optimized image token from Angular Common. And again, this is a standalone directive, so you can just import it directly. And then in our HTML, if we want to start with all the images below the fold, so this ng4 here, to convert it to use the image directive, all we have to do is change source to ng source. And it's converted. So now if we, if we refresh the page, you can see that these images should still load and they still seem to be working. Okay, so now let's go ahead and convert the hero image at the top. So we'll change source to ng source. And then we'll, let's see, oops. Refresh the page here, still seems to be working. Okay, and then over here you can see that we have a number of warnings in the console. And this is actually one of the coolest parts of the image directive, I think, is that it can observe the loading of your application, look at its performance characteristics, and make a bunch of suggestions to you about how to better use the image directive and any other things that you should be doing related to images. So if we look at these warnings here, let's start to resolve some of them. Okay, so this is a good one to start with. It says the image directive has detected that this image, so this image right here, is the LCP element, but it was not marked priority. And it's suggesting that to fix this, add the priority attribute. So basically it's saying, this is your LCP element, but you're treating it the same way as you're treating all of the other images that you can't even see. That doesn't make sense, so you should add priority here. And you might wonder, if we know enough to show you a warning that you're not boosting priority enough, why doesn't the directive just do that for you? And the quick answer is that by the time the page has completed loading and we have this information, it's too late to do anything about prioritization. So we ask the user to add a priority attribute. Okay, so let's keep resolving these warnings. What's the next one? Okay, so this is a good one. It says the directive has detected that there is no pre-connect tag present for this image. Pre-connecting to the origins that serve priority images ensures they're delivered as soon as possible. To fix this, please add the following element to the head of your document. So I'll go ahead and add this here. And if you haven't seen pre-connect resource hints before, basically they're telling the browser, hey, you haven't seen this origin before, but you're going to see a resource that's really important with this origin somewhat soon, so just start connecting as soon as possible. Okay, so let's keep resolving warnings here. Okay, so it says, it looks like your images may be hosted on the ImageX CDN, but your app is not using Angular's built-in loader for that CDN. We recommend switching to use the built-in by calling this provide function. So the image directive comes with a number of preset configurations for common image CDNs. One of those is ImageX. So you can see in our component TypeScript that all of our images are coming from this ImageX CDN. So what we should be doing is using the built-in configuration for that. So we can go ahead and in our providers, add provide ImageX loader. And then we want to pass in the base URL of our ImageX instance. So if you go back here, just grab this part. Drop it in there. And then there's an additional DX benefit where since we have the shared URL, you don't have to type it everywhere. We can just construct that for you. Okay, now we have one last warning to resolve. which says that the directive has detected that the intrinsic image is way larger than it needs to be. So here you can see that the rendered image size is like 344 pixels because it's a mobile device. But the image size that we're downloading is 2,600 pixels. So that's obviously wasteful, right? We're spending way too much time downloading a giant image. So it suggests that we can either resize the image or we can consider using the sizes attribute to implement responsive images. So for this one, we don't really want to resize the image because we want our cat to grow as the device size grows, or shrink as the device size shrinks. So we're going to go ahead and make it responsive. So in our case, we want the image to always match 100% of the viewport width because that's how we're displaying it, right? So here we can add sizes equals 100 VW, and then that will generate a source set so that it's always requesting an image closest to that size. So if we refresh the page here, you can see that the warning is gone. And also, if we hover over the image in DevTools, you can see that we're now requesting an image that's 1080 pixels wide. So it's about half the size of the image we were requesting before. Quick side note, you might wonder why that's still 3 times the size of our rendered size. And just a reminder that we're looking at, or we're emulating a mobile device, and it has a pixel density of 3. So we want to multiply it by 3. So, okay. Great, so now we've converted our whole application to use the image directive. We've resolved all the warnings. Let's go ahead and check how this affected performance. So if you go back to my presentation, okay. So I generally like to use web page tests to do my performance profiling. And for things like this, you want to run them at least 9 or 10 times to account for things like latency, network connection, that kind of thing that can vary from run to run, and then take the median, so that you guys don't have to watch me run web page tests 10 times for each step. I did this ahead of time. And I looked at the performance profile before we made any of our changes, so with just our native image tags, and then after we made all the same changes that we just did together. So before our optimizations, the LCP at median was 7.8 seconds on an emulated Moto G4 device. After all of the changes that we just made, we got the median LCP down to 2.2 seconds on the same device and the same connection. So that's over 5 seconds of improvement in the median LCP with just a few performance tweaks. So why? Like, why was our original app so slow? Why did the changes that we just made make any difference at all? So this next section, I'm going to go through all of the steps that we just went through in the demo, and I'm going to explain why they improved performance. And to do that, we're going to look at a bunch of waterfalls. So this is a waterfall of the app at the beginning, right, before we made any changes. I guess as a side note, if you haven't encountered waterfalls before, they're a list of requests that are made by the browser over time. So this y-axis here is all the resources that are being requested, and the x-axis is time in seconds. Okay, so to understand why the app is slow, let's go step by step through what happened. So the first thing that the browser does is it requests the document. And you can see the blue bar here, it's kind of tiny, is where the document's being downloaded. So the browser will parse the document. It'll start encountering, your style sheets and your script tags. And so it'll start requesting your style sheets and your script tags. You see them show up here. And these yellow bars are where your JavaScript is being downloaded. Once the JavaScript is downloaded, it starts executing your JavaScript, your Angular app bootstraps. This is when your Angular templates start being added to the DOM. And so the browser discovers your image tags that you've added. And before it can even start requesting the images, it has to connect to the image CDN origin. That's what this green little, candy cane is. And then once it's finished requesting to the origin, it starts requesting all of your images. It finishes downloading your LCP image, and so you see an image on the screen, and then eventually all the other images complete loading, and the page is finished loading. Okay, so why is this slow? What's wrong with this waterfall? A good place to start is, again, by looking at your LCP element. So if you take a closer look at this, you can see that the purple bar runs from 2 seconds to 8 seconds. So it takes 6 whole seconds for this image to download. So that's obviously too long, right? And if you look even closer, you can see that the purple bar has dark purple stripes and light purple stripes. The dark purple stripes represent where the image is actually downloading, so bytes are going down the wire. The light purple stripes are when the connection is idle, so it's when nothing is happening. And the reason that this particular bar is so stripy, it's so inefficient, is because of resource contention. So we requested all 7 images at the same time, and the 6 images that are beneath the fold, the ones you can't even see, are stealing bandwidth away from the image that we actually care about. And that's why you can see that these dark purple chunks in the lower images line up with the light purple chunks in our LCP image. So what can we do? Well, the general advice for resource contention is to try to lazy load anything that's non-critical. And that's actually the very first thing that we did, though you may not have realized it. As soon as we added the image directive, so when we changed source to ng-source, we turned on lazy loading for all of those images because the directive does that by default. And I can show you very quickly. If we go to the network tab, that's not the network tab. And start over here. Oh, I think this is, can't see the bottom. Hold on. Can I? Okay, well, I guess you'll have to trust me since I can't seem to get this resolution to show the network thing at the bottom. But it'll just request the images one at a time as they scroll into view. And under the hood, what it's doing is it's adding this native HTML loading attribute to the image tag and setting it to lazy. So this loading attribute has been around for a few years, but it's only this past year where it's gotten full cross-browser support. So now you don't have to use a lazy loading like JavaScript library, you can just go ahead and add this attribute. So once we started lazy loading the images beneath the fold, we see a really big difference in the waterfall. So this is the waterfall after we made that change. So if you look at the bottom here, we no longer have 7 images being requested, we just have the 1. And if you look at the purple bar, it's a lot more efficient, right? It's like one big dark purple chunk. And that improved our LCP by over 2 seconds, from 7.8 to 5.1. But we still have some issues. So another thing we want to address is something called resource load delay. So you can see that there's a 800 millisecond period between when the document is downloaded and ready to request things, and when we first start trying to connect to the image origin. So we want to try to move that over to the left if we can. And the way to do this is to boost the priority of your LCP image. And again, this is something that we did together. If you recall the warning telling us to add this priority attribute, as soon as we added the priority attribute to our image tag, under the hood, the image directive did 2 things. So the first thing it did was set the loading attribute to eager. This means that the LCP image isn't going to be lazy loaded, which is really important. And the second thing is that we added Chrome priority hints API. So this fetch priority equals high tells the browser that this image is super important and that should be prioritized above, most other things. And then we did one other thing that the warning told us to do, which was we added this pre-connect resource hint. So with those 3 optimizations, if we look at the waterfall again, you can see that we start requesting everything a whole lot sooner, right? So if you look at how it was before, you can see that it's really moved up. So with that change, we shaved about 500 milliseconds off. But again, this still isn't a great LCP, so we still have more work to do. So if you look at the purple bar, it's still too big, right? It still takes 3 seconds to load this image. So that tells us the image size is probably too big. So common advice there, make sure that you're optimizing your CDN configuration. And that's something that we did. We added the provide ImageX loader built-in provider. And in our code here, you can see that in addition to constructing the URL, we added this auto equals format flag. And this is important because in ImageX, what this does is it turns on a mode where it will request super modern image formats for browsers that support them. So even though we uploaded JPEGs, what we actually got in the browser was AVIFs, which tend to be 20%, 30% smaller. And the last thing we did was we implemented responsive images, or another way to say that is we made sure that we were requesting images that were appropriate for the size of the device that we were viewing them on. That's when we added this sizes attribute. And under the hood, what this did was it generated automatically a source set attribute. So if you're not familiar with source sets, it's essentially a list of source URLs that you're giving to the browser at different widths. So you're basically saying, like, I have all of these widths for this image available at these URLs. Please choose the URL or the width that's most appropriate. And then it has the flexibility to request a smaller image if it needs to. Okay, so with the optimal CDN options and with the responsive image optimization, we're able to reduce our load time from 3 seconds to 500 milliseconds, which gets us down another 2 seconds to 2.2 seconds. So very quickly, I just wanted to show you the before and after. So the before is on the top, the after is on the bottom, and there's 1 second between each frame, just to show you kind of the real difference in user experience that it can make to make some of these smaller changes. So that's it. So I just wanted to put a tagline here to try out the image directive. If you haven't tried it, please give us feedback. We're anxious for feedback. You can tweet at me, file a GitHub issue. Thank you.